Okay, so this is our 10th week. I'm going to cover just a few topics from chapter 12. It's just going to be very brief, and then the rest of the time I'm going to cover confidence intervals and hypothesis testing more in depth. Okay, so we'll get more in depth on confidence intervals and hypothesis testing. Make sure we have a good understanding of that. And we'll begin our our review as we ramp up towards the final exam. So this week you just have a few very simple problems for your homework. Okay, just from chapter 12. It's just a few topics on sampling methods, and then your primary homework this week will be to do the practice final exam. So I have posted on Canvas the practice final exam, which I feel is fairly representative of the final. So your homework this week, I've gotten a few emails about missing reference tables or students who have misplaced theirs. They're available in week 5. You can just download them and print them out. Okay, so your homework this week is to work on the practice final exam. The practice final is right here. Okay. You also have, I've created kind of two maybe study aids. So one is a formula sheet, okay, which provides all of the formulas that you need for all of the stuff we've covered. So we've got confidence intervals for proportions with one sample. The formulas appear here. Hypothesis test for proportions of one sample, hypothesis test for proportions of two samples, confidence intervals for means of one sample, confidence intervals for means of two samples, hypothesis test proportions one sample, and hypothesis test proportions two samples. So these are all this is a formula sheet that you can use, or I also kind of have a guide for inference. It says study guide, but it's really mostly a guide for inference that kind of breaks it down into a little bit more, it's a little bit more verbose. Okay, so depending on what works best for you, you can use either one. Okay, for the final exam, you are allowed to have one full sheet of paper with notes on both sides. Okay, if you want to use either my formula sheet or the kind of guide for inference for either of those, you are welcome to do so. You don't have to. You can write your own formula sheet out and write on it. You can print out mine, and then in all of the blank space. So this is one page. So if you use this one, you have a completely blank other side, and then there's also lots of white space that you can fill in with other text. With this one, it's mostly filled out. There is some white space, and you can write stuff in those spaces as well if you want, or if you want a completely blank page, that is an option for you as well. Okay, so for the final exam, I recommend starting to kind of work on your note sheet now, because this week your homework is to work through the practice final. And so when you work through the practice final, I highly recommend, you don't have to do it all in one sitting, but I highly recommend kind of sitting down and trying to work through as much as you can without the use of the textbook or without the use of your notes. Okay, so try to work through it on your own using just your note sheet. Okay, because you want to use the practice final as an opportunity to practice. Okay, and so you want to put yourself into test-like situations. So I recommend the way the practice final is structured. there's kind of chunks of maybe 5 or 6 questions at a time. And so I recommend, giving yourself, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I'd say give yourself about 15 minutes or less for each chunk of 6 questions. Okay, they're kind of broken out in that way. And so, yeah, give yourself about 15 minutes. See if you can work through it without any outside help. Okay, and I think that's probably a good way to practice. You set the clock. Say, I'm going to try to get through these 6 questions within 15 minutes. Okay, don't look at your notes. Only have your OneNote sheet, your calculator, and your reference tables. Pretend as if you are in a test-like situation. See how much you can do, and I think it will reveal, areas where you are weak, and things that you can work on. There's a question.
But we have a quiz next week, right?
You do have a quiz next week, okay?
Up to with this?
No, so the quiz next week. So I have the traditional info about next week's quiz, and I have a practice quiz there. Okay. So so this is kind of just questions about the sampling methods that we're going to cover today, along with topics regarding power and whatnot. Okay. So all of this stuff is available. So please study this, and then regarding the doing your homework is to work through the practice final. So, of course, study for the quiz as you always do, but also work through the practice final. Okay, because next week I'll spend our time kind of explaining everything as we work through the practice final, going over all of the answers, making sure everybody understands how to do everything. And I feel like if you can work through the practice final and do well on the practice final, especially in those simulated test-like scenarios, you'll be well poised for the actual final exam. Okay. All right. Questions? Feeling okay? No? Okay. Well, it's just we just got one more week of stuff, and then it's the final exam. So in 2 weeks, that'll be my last time seeing you guys, unless our paths cross again in the future, which they might happen. Because some students transfer into UCLA, and I've run into some former students who transferred into UCLA, and it's always it always brightens my day to run into former students like that. So I might not remember every single one of your names, but if you say, hey, you were my XL10 teacher, then I would say, oh yeah, that's great. So it's always good. So
But would you remember our names, or just no?
I might not remember your names. I generally remember your faces. Okay, I'll remember your faces, but I might not always be able to put a name to your face. Okay. Or if you give me your last name, I might remember your first name. So somehow my brain can pair certain things, but other things it has a hard time, right? Okay, so let's cover these sampling methods from chapter 12, and then we'll kind of start our kind of a review of inference here. Okay. I think this projector is just getting old and weak. I've turned off the front lights. I think the projector is just dim, and I don't know how to change that. You can sit up here, and there's this projector as well, if that is preferable. Okay. So this will be chapter 12. Just there's only just one section. I can't remember which section it is, and we're just going to talk about sampling methods. Okay. So first of all, kind of what is what is the idea of sampling? Okay. Well, sampling is the method that we use to select individuals from the population. Okay, so we're going to select individuals from the population, and, you know, ideally, the members selected, the people selected, okay, so ideally the people selected are representative of the population, and that's what we want. We want the sample to represent the people in the population, and that way when we observe the sample and make conclusions about the population based on the sample, we can be confident about those conclusions, right? So this will allow us, you know, to generalize our findings from the sample to the population. Okay, and so we've already talked about one sampling method. Okay, so many of our inference techniques Okay, so many of our inference methods assume that we used simple random sampling. Okay, so this is kind of the sampling method that we have covered so far. Okay, so SRS, this is simple random sampling. And so with simple random sampling, the way we do this is we need to have a list, or we need to have what we call a sampling frame. Okay, and the sampling frame should be a list of everyone, all things in the population. Okay, so that's what we desire. We want our sampling frame to have everyone in the population. Okay, if the sampling frame does not have everyone, then your sample cannot be representative of everyone. Your simple random sample can at best be representative of the sampling frame. Okay, so ideally your sampling frame reflects everyone in the population. If it doesn't, then your random sample will have the same deficiencies that your sampling frame does. Okay, so if you know, today I don't know what what we could use to possibly have a sampling frame. We used to have phone books, and that would kind of list off everybody, and you might be able to pick names at random from a phone book. But today, I have a high doubts that many of you are listed in the phone book, okay? And so if we were to use this phone book to perform simple random sampling, none of you would have a chance of being selected for our sample, okay? So our sample would not do a very good job of representing many of you, okay? So today, maybe a modern equivalent of kind of a phone book listing could be maybe Facebook, okay? So I presume that many of you have Facebook. Many of you might not, okay? And so that might do a better job of trying to be representative, but many of you may choose not to have a Facebook profile, okay? And then Facebook probably won't even let you do random sampling with their data. They probably won't give you access to their data, but maybe you had some way to obtain that. Perhaps that could help you get a good sample, but at the same time, it's not, anybody who's not on Facebook will not be represented, okay? And so, you know, think of people who would be represented by phone books, think of people who would be represented by Facebook. You're gonna have probably different populations represented there. So depending on how you do select your sampling frame is gonna determine how your sample's selected, okay? So the sampling frame should be a list of everyone in the population. If it is not, your sample will have deficiencies. Is that how you spell deficiencies? I before E except after C. I don't know how to spell deficiency. All right, that's even worse. Okay, whatever. Okay, something deficiency. All right. So the way it works is with the sampling frame. Select individuals one by one at random. Okay. The selected people will be your random sample. SRS, simple random sampling, should give you a representative sample, but because it's random, it is not guaranteed that you will have a representative sample. Okay, so that's what we have, simple random sampling. Okay, other sampling methods. All right, if I may flip to the next page. Wait. Okay, I'll wait. Okay, now? All right, I am gonna go anyway. Okay, so other methods include systematic sampling. Okay, systematic sampling. I think this one's easy to understand. This works best for if there is a line or a queue, and basically you just select every 10th person in line, or select every just some number, nth person. Okay, so in this, so if you select every 5th person in line, that is systematic sampling. Okay, so nth just is a Q. That's a weird word. Q-U-E-U-E. It's like all these vowels decided to just keep going. Okay, we have stratified sampling. Okay, so with stratified sampling, the population consists of kind of distinct subgroups called strata. Okay, the strata, are all each strata has the kind of like a trait that defines them. Okay, each strata is defined by some trait. Okay, so examples of strata would be, dividing the population by gender, okay, or by race, or by occupation. Okay, occupational category. All right, so there's something. You divide the population into different groups based on some kind of trait. All right, so if you divide by gender, you're probably only going to have 2 groups, maybe a third group if there's people who don't decline to state, or unknown, or choose not to identify, or whatever. Okay, or by race, however many categories you have, or occupational category, you could choose 15 categories or 5 categories or something. Anyway, you have strata. Okay, and then when you select your sample, you make sure each strata is represented. Okay, and then, and if you have this information, you make sure the strata are represented in the appropriate proportions, or in the appropriate amounts. Okay, and if possible, make sure the strata are represented in the appropriate proportions. Okay, so for example, let's say the population is the US military. Okay, so there's lots of people in the military. And let's say you're going to select a sample. We're going to choose for our strata gender. Okay, and so you'll have, so the military is mostly male, but there are also many females. Okay, and so let's say we know, and I don't know what it is, but let's say the percentage of males is something maybe like 83%, and the percentage of females is 17%, okay, in the population. Okay. So if you want a sample, so, you know, when selecting a sample, okay, instead of just randomly selecting people from the military, this is one way to get a sample. If we're going to do stratified sampling, what we're going to do is we're going to make sure we get males, and we're going to make sure we select females, and we're going to make sure that our sample is 83% male and our sample is 17% female. Okay, so when selecting a sample, we will make sure that the sample is, you know, 83% male. So if you have 100 people in your sample, you're going to pick 83 of them to be male, and you're going to pick 17 of them to be female. So our sample reflects the makeup of the population. Okay. Now this may or may not be the best method. Okay, you know, so if you're trying to get statistical samples, stratified sampling is a good way. Okay, but you know, if you're forming a committee, you might want a different selection criteria. Okay, so for example, if you're trying to create a committee on you know, recruiting more women to join the military, you will probably want your committee to have more females on it than males, I would imagine, okay? Who knows, all right? So, you know, selecting people to join a committee or whatever, that's going to be different from a representative sample. But if we're talking about statistical samples and whatnot, stratified sampling is one way to do it, okay? Of course, you know, that also requires that we know the proportions that exist in the population. And, you know, I don't know, 100%, okay? Okay, so that's stratified sampling, okay? Contrast that to cluster sampling, okay? Okay, so also in cluster sampling we have subgroups of the population, okay? So the population is divided into subgroups called clusters. Clusters, okay? And generally there will be many clusters, okay? Many clusters, and the clusters need not be kind of homogeneous or uniform, okay? So there are many clusters, and the clusters do not need to be homogeneous, okay? So it doesn't have to be clusters based on gender or whatever. Actually, it's better if they're not, okay? And to perform cluster sampling, okay, generally, we like to use cluster sampling, okay? So we use cluster sampling if it will be difficult to get a list of everyone. Okay, but easier to get a list of the clusters. Okay, and then what we will do is we randomly select some clusters okay, and then and with these selected clusters, we can either survey everyone in the cluster if that's possible, or we perform random sampling within those clusters. Okay, so for example, okay, let's say you wanted you want to get your population of interest is everyone who attends church in LA County. Okay, this would be a difficult population to get a list of every single person. Okay, it would be very difficult to try to get a list of everyone who attends church in LA County. Okay, it is, so I'll write difficult to get a list of everyone. Okay, but it is relatively easier to try to get a list of all the churches that exist in LA County, okay? And maybe you're gonna miss some itty-bitty churches, but I imagine it'd be relatively easy to kind of at least get a list of you know, physical buildings that are churches and things like that, okay? So it's easier get a list of all the churches in the county, okay? All right, and there's probably hundreds, if not thousands, of churches, okay? And then so what you'll then do is you will take a random sample of your list of churches, okay? So then okay, so maybe you select 50 random churches, so, you know, $50 of the churches on the list. Okay, and then with these 50 selected churches, you would then go to those churches and then try to select individual people, okay? and that would be cluster sampling. Okay, so it's very different from stratified sampling. With stratified sampling, you have different subgroups, but you want to make sure every subgroup is represented. Okay, and then with cluster sampling, you've got a bunch of different subgroups, and you're not going to try to get all of them represented. You're just going to try to take a random selection of those, random selection of the clusters, and then you perform sampling within those clusters. Is that okay? All right. So perhaps we'll try a few examples. I'm going to yeah. Okay. So name which sampling method is used. And your options are simple random sampling, stratified sampling, cluster sampling, or systematic sampling. Okay. All right, so this one. Okay, so we will say at a fast food drive-through, the attendant gives a card, or I'll say a coupon, asking for a survey to every 8th person to drive through. Okay, so don't shout out your answer. Okay, so we'll say a local library takes a list of all of its members. I'll say patrons. So, and it randomly selects 120 people from the list. Okay. They flag these patrons to ask for their opinions. During their next visit. Okay, and then we'll say, okay, a state is divided into 55 counties. The state government decides to randomly select 10 counties and survey the residents in the 10 selected counties. Okay, so go ahead and think about each of these for a minute or so, and see if you can identify which sampling method is used for the given scenarios here. Okay. Well, let's look. All right. So this first one, the fast food drive-through. We're going to give a survey to every 8th person to drive through. What's that? Systematic. Great. Okay. The local library. We've got a list of all of its patrons, and we're going to randomly select 100 people, 20 people from that list, and then we're going to ask for their opinions during their next visit. This is going to be simple random sampling, okay? Simple random sampling because we're taking a list of all of its patrons. So we have a list of the entire population, okay? So because we're doing that and then we're just randomly selecting from that list, that's going to be simple random sampling. Okay, and then number 3, the state's divided into 55 counties, and we're going to randomly select 10 of those counties and survey the residents. What's that? This is going to be cluster sampling, okay? We know it's not stratified sampling because we're not going to make sure all 55 counties are represented, okay? If it were cluster sampling, then there would be something about trying to make sure that all 55 counties are represented. But because not every single one of those subgroups are going to be represented, and we're just selecting some of those, that's our indication that it's cluster sampling. Okay? Are we feeling okay about this? Should I give an example of the stratified sampling, or are we feeling okay there? We're good? Okay. All right, why don't we take a short 10-minute break here? I guess, well, long or short, 10 minutes is 10 minutes. So we'll take a 10-minute break, and then we'll come back and we'll start covering a little bit more on the statistical inference and whatnot.